Okay, today we're going to look at word problems with quadratics. So let's highlight our title there, and that's what we're going to focus on. Okay, notice, since it's word problems and we're creating an algebraic equation or expression here, we need let statements, so we need to see what we're trying to find. So one number is 5 more than the smaller. Their product is 14. So smaller is at the end, so I'm going to write let x equal smaller number. The other one, let x plus 5 equal larger number. I've got my two let statements. Their product is 14. That's where I'm going to develop my equation. So I've got the product means to multiply the two, and that equals 14. Okay? So I'm going to distribute x squared plus 5x, and I'm going to bring the 14 right over, so minus 14 equals 0. And I've got it in standard form, which you can see in the directions. It doesn't tell us to round anything. It doesn't say irrational expressions or anything like that. So I'm assuming I'll probably be able to factor this guy. So I'm going to write down my factoring, which is x plus 7, x minus 2 equals 0. Split it. So I've got x equals negative 7 and x equals 2. Okay? So in this problem, it doesn't say that they have to be positive or negative. Okay, so there's nothing that I have to reject yet. So I'm going to try 2. If I put 2 into the smaller one, 2 is a smaller number. 2 plus 5, 7. So that's one pair of solutions. The other one I'm going to take is negative 7. Put negative 7 into the smaller x, and then negative 7 plus 5 gives me negative 2. So I've got my two pairs of solutions for that problem. Okay? Let's try number 2. It says 3 consecutive positive integers. And let's not forget that they have to be positive. That's going to help us out at the end. So let's set up our 3 let statements. Let x equal the first consecutive integer. Let x plus 1 equal the second consecutive integer. And let x plus 2 equal the third consecutive integer. Now let's read how we're going to come up with our equation. The product of the second integer and the third integer is 20. My second integer is x plus 1. And my third integer is x plus 2. And it says the product, so I'm multiplying them to equal 20. So we're going to FOIL x squared plus 1x plus 2x plus 2 equals 20. And then we're going to put in standard form, so I'm going to subtract the 20 over, and I'm going to simplify, which gives me x squared plus 3x minus 18 equals 0. Now let's factor x plus 6, x minus 3 equals 0. Set them up. Now you could write x plus 6 equals 0, x minus 3 equals 0, but in the end it does the opposite of your factor, which would be x equals negative 6, x equals 3. Now let's look back up at the problem. Positive integers. Negative 6, of course, is not positive. I'm going to cross it off, write the word reject. So 3 is my x value. 3 is my first integer. Plus 1, 4, plus 2, 5. There's my 3 consecutive positive integers for that problem. Okay, let's turn the page. I mean, this is the same 3 and 4, same idea, but let's turn the page and let's look at number 5. A little bit different. So on number 5, a rectangle is 6 feet long and 4 feet wide. Whenever I see a rectangle problem, I draw the picture. So I've got 6 feet long and 4 feet wide. Each dimension is increased by the same number of feet. The new rectangle, whose area is 39, so I'm just going to kind of set up a word equation here. So the new rectangle area, put a little A for area there, is equal to 39 feet more than the area of the original. So I'll do the original area plus the 39. Okay? So the dimension that they want to increase by is what we're trying to find. So I'm going to just do a little let x equal increase. Okay, whatever you're trying to increase it by. So maybe I'll draw a new rectangle over here where I have room. Increase the 6 by x, I got x plus 6. Increase the width by x, I got x plus 4. So the new area, length times width, is going to be x plus 4 times x plus 6 equals the original area, which 4 times 6 is 24 plus 39. Okay? So now I'm going to FOIL, and I get x squared plus 4x plus 6x plus 24 equals 63. Bring the 63 over, simplify, and that's going to give me, bring it over there, so I've got x squared plus 10x minus 39 equals 0. Simple AM method of x plus 13, x minus 3 equals 0. And then I t-chart it, and I get x equals negative 13 and x equals 3. This is a real-world dimension problem using length, so negative 13 would not make sense, so we're going to reject that guy. So x equals 3, and all they wanted was the increased dimension, so there's my answer. Okay, now number 6, I'm just going to give you a little hint on that, and I'm going to tell you what the answer is so you can try it on your own. How long will it take for him to hit the water? The height is h, the t is your time. Okay, it's like a diver is standing on a platform a certain height up, jumps, and then when he comes right here, this is where h equals 0. That's the height right there. So I'm going to say, hit the water, I know the height has to be 0. So very simply, I take the equation for the quadratic they gave me. Now v is the velocity, they give me 8, put it in for the v. S is your initial height above the ground, 24. And all I know is that height is 0, so I put a 0 right in for the height. And there we go. Now I would probably make the negative 16 positive, so I could pretend I'm kind of bringing everything to the other side, or just multiply every single piece by negative 1, and that's going to be 0 equals 16 t squared minus 8t minus 24, which has changed all your signs. In the end, after you do all the work, pulling out the GCF, doing all your factoring, the time will be 1.5 seconds, so you can try that one. Okay, the last one I'm going to try for today is number 7. The measure of one right triangle. That gives me a hint right there. I'm talking about the sides. I remember that I had this little formula called the Pythagorean theorem for right triangles. A is a leg, B is a leg, across from the 90 is your C, which is your hypotenuse along this side. They say the measure of one leg of a right triangle is 7 meters more than the measure of the other. Maybe I'll put it right on my picture. So the measure is 7 meters more than the measure of the other. So maybe I'll call this one x plus 7. I'll call this side x. And I'll call this one 13. That's your hypotenuse. Using my a squared plus b squared equals c squared, my Pythagorean theorem, let's put in our values. X plus 7 squared plus x squared equals 13 squared. Now be careful with this guy, don't just distribute your exponent. It's not power of a power here. You actually have to write x plus 7 expanded out, plus x squared equals 169. So I'm going to FOIL this, bring this over. In the end, you should get 2x squared plus 14x minus 120 equals 0. Pull out the GCF of 2. Always look for that GCF first. Equals 0. Let's just bring it up here. So I've got 2, FOIL that, which is going to be x plus 12, factor, x plus 12, x minus 5 equals 0. Set each of those pieces equal to 0. 2 we know cannot be 0. X would equal negative 12, and x would equal 5. Can't have a negative side, so we reject. So you've got X is 5, and they want the measurement of the legs. There's 2 of them, A and B. So 5 is the one, 5 plus 7, 12 is the other. Okay, try out that homework, check your answers online.